Good morning once again. We're going to continue our discussion on time series, in particular, the modeling of using ARIMA, no? Autoregressive integrated moving average. So these were the packages that we required. So kindly make sure that these packages are already loaded, in particular CTSM. Okay. So last time, what we did was to learn how an ARIMA model, how we model an ARIMA, no? An ARIMA process, whether it's AR or MA or combination. Okay, just quick review, guys. Sabi natin, for an AR process, we're regressing or we are modeling our time series based on past values of itself. An AR2 process means that you're modeling your time series based on the first and the second lags. Okay, two lags. On the other hand, an MA process is one where you model your process based on its past error terms. No? So ito, B1 times epsilon sub t minus 1. Okay? All right, so this is your MA process. A combination of AR and MA is what we call an ARIMA process. So you have here as a regressor the past values of itself and the past error terms. Okay, before you can model a time series as an AR or MA or ARIMA process, you have to make sure that the time series is stationary. So what do you mean by stationary? No trend, no seasonality, no and the variance is constant across time. If it's not stationary, then we have to do some transformation. Okay, when we transform the data, okay, we mean when we transform the data, it's then that means that we're creating another data set. So, for example, if the data has if the data is has a trend, then how do we remove the trend? We remove the trend by differencing it. So when we difference the data, we're not going to work anymore. We're not going to model anymore the original data. What we're going to model is already the difference data set. Okay, so by differencing the data, that will remedy your trend. On the other hand, if the data has non-constant variance, then what we usually do is to get the log of the data. And of course, if you get the log of the data, then you have another series. You have a different series already. You have the log of the data and not the data itself. Okay, so the log transformation will not remedy the trend. Okay, it will only remedy the non-constant variance, but not the trend. How is the trend remedied? You get the differencing. Sometimes our data can have non-constant variance and can have a trend. So if you're, for example, dealing with sales or stock prices, and if you need to transform the data because the data has both trend and seasonality or non-constant variance, then what we can do is first get the log of that data and then get the difference. Now that's, of course, you can also get the difference first and then get the log. The problem with doing the first one is that when you get the difference, that might introduce negative values. And if you have negative values, then you will not be able to get the log of those values. So one way to go to remedy this is to first get the log, okay, and then once you get the log, you get the difference. Okay, all right. So once you have the stationary data series, then you can easily apply the ARIMA. Okay. Now, how do you determine if a process is AR or MA? You have to look at the ACF and the PACF. Okay, this was of particular importance before when, oops, I'm sorry, I'm looking at a different file. Okay, this was of particular importance before when we didn't have softwares like R or Python. Okay, but nowadays, guys, it's even not necessary to plot your ACF and your PACF in order to determine the type of ARIMA process of the data that we're modeling. So we learned last time that in order to determine if it's an AR process, you look at the PACF, the partial autocorrelation function. The nature of the PACF of an AR process is that it has significant spikes at certain lags. So it can be a significant spike at lag 1 and no more significant values at the other lags. So that's indicative that this could be an AR1 process. Okay. On the other hand, if you want to see if it's an MA process, you look at the ACF, the autocorrelation function. If there are significant lags, then that could indicate that it's an MA process. If there's a significant lag at the PACF and the ACF is a slow decay, okay, that's indicative that this is strictly an AR process. And then yung vice versa, if your ACF has a significant spike at a certain lag, and then the PACF is slow decay, then that could indicate that it is a strictly MA process. If both ACF and PACF have significant spikes at certain lags, then that could indicate that it's an ARIMA process. Okay. Now, nowadays, guys, we can make use of the ARIMA function of R. The ARIMA function, in the ARIMA function, R will be the one to difference the data for us. So it's really a lot easier to model a time series now using the Box-Jenkins approach, using these softwares. Madali na talaga siya. Okay, so last time, guys, we used the ARIMA.sim function. That's from the stats package. This will allow us to generate a time series with these characteristics. So dito ang ginawa natin, guys, nung una, no? I hope if you haven't loaded this, paki-load ulit. Very quick review lang tayo dito. So sabi natin ARIMA.sim yung function. We're creating this object called x1. And then n is equal to 1,000 observations. And then here we're defining ano yung AR component niya at saka ano yung MA component. Of course, it can just be a simple AR or a simple MA. No? Dito kinumbine na lang natin. And sabi natin, guys, yung AR component natin, dapat all of your A1s, A2s, A3s, etc., all of your coefficients should be less than 1. So this is okay. This is okay kasi less than 1 sila. And also the sum A1 plus A2 should be less than 1 also. So this is okay also kasi if we add these two coefficients, it's less than 1. Okay, for the MA, ganun din, guys. Okay, less than 1, that's okay. Add the 2 less than 1, that's okay. Right? And then we suggested a standard deviation, which is just the square root of a certain number. Okay, so let's, if we run this, guys, very quick lang. So we should have the first 10 values dito, no? Head ng 10. So we should have the same values kasi nag-set that seed tayo. Okay, that's the beauty of random generator na sinaset natin yung a certain seed para so that we have the same values. And what we did last time was to plot this, and we can see here that the plot of our data set of our time series X1 is stationary. Kasi nga, guys, ang ARIMA process is stationary yan. Stationary siya. Tingnan natin, walang mean, walang trend, okay? Okay, and walang the variance is constant across time. Okay, to take a look at this. Yung mean natin naka-center sa 0 dito. Tapos wala naman siyang trend. And then medyo constant yung ano natin, no? Yung volatility natin, constant yung variance natin. Okay? Sabi ko nga later on, guys, there will be instances na yung data natin nagkakaroon ng malaking dispersion dito, tapos medyo ganun, tapos ganun na naman, ganyan, no? Nagkakaroon ng ganyan. Pag ganyan guys, just looking at this visually, it's best to model this not using ARIMA, but rather another process, which is what we call your arch. Arch, AR, arch, no? Arch or Garch. So that will be our next lesson, no? How to model a time series if it has arch or Garch components. Arch means autoregressive conditional heteroscedasticity. So ibig sabihin, for at certain points, at certain levels, at certain time periods, yung ano natin, yung variance natin hindi constant, no? Meron tayong heteroscedasticity, meron tayong tinatawag na volatility, no? And volatility clustering. Nagsasama-sama, yung volatility clustering means where time where the prices or the returns keeps on increasing, and it leads to more increases, more increases, more increases. Or periods where it goes down and then goes down again, continues to go down. So that causes what we call the volatility clustering. And that's better modeled not using ARIMA, okay, but rather Garch. No? Okay, we'll go to that in the next sessions. Okay. All right. So okay, so itong model na to guys, diba? Gamitin natin si TSM para makita kagad natin yung ano yung ACF natin at saka PACF. So this is just a quick review guys. It pays to review concepts like this kasi guys hindi madali yung ano no. Hindi madali yung concepts ng time series, no? Okay, ito tingnan niyo guys, no? Ito we can see here that in the PACF that a candidate for AR process. No? Significant spike at lag 1, lag 2, and even at lag 3. And then wala na. Si ACF naman guys, significant spike at lag 1, lag 2. Tapos meron pa dito 3, 4, 5. And then dito meron pa sa 13, 14, 15. So medyo mahirap i-spell talaga kung MA process to, no? Kasi parang slow decay din siya, no? Pero hindi naman, mukha naman hindi slow decay. So this is indicative that this might be also an MA process. So significant spikes at the ACF and the PACF lead us to conclude that this could probably be an ARMA process, ARMA process. So dati guys, isa-isihin namin yan, no? Itingnan namin, ano ba to? ARMA 1.1 ba to? ARMA 1.2, ARMA 1.3, ARMA 3.1. So it's quite, it's really quite unwieldy, no? Okay, sandali lang guys, sandali lang. Sorry. Very sorry about that, guys. Sorry, dumating kasi yung may nilad kasi may leak yung sa pipe. Okay, so as I was saying, guys, diba, it's important dati, at least dati, no, to identify kung ano yung possible na model ang gagamitin dito. AR ba to? MA ba to? Pero trial and error to, no? Ngayon, which we showed last time, hindi na kailangan kasi yung software na magdedetermine, magbibigay sa atin ng ng model itself, no? Okay, here we're testing. Bago natin usually i-model yung isang time series, i-test muna natin kung ano ba siya, kung stationary, no? But here we know that this is stationary kasi X1 was generated by ARIMA simulation. Pero kung hindi natin alam, syempre, i-test muna natin kung stationary siya. And here, we can see that the null hypothesis here is that the time series is not stationary. Kaya nga yung alternative stationary. And we would want to reject that null hypothesis. No? So ito, p-value is 0.01. So we reject the null hypothesis that the series is non-stationary. So okay, stationary in series. So we can proceed, no, with our modeling. Ito, I think we also discussed this as an example. Difference natin, which is not needed anymore kasi ano na siya, di ba? Stationary siya. So no need to difference that data set. At saka mas mahirap, guys, i-interpret pag naka-difference yung data natin, no? Kapag naka-difference na yung data set natin. Okay, so okay, let's skip this. Let's skip this. Okay, ito quick review na lang, no? This one, itong ARIMA, guys, hindi siya ARIMA.sim, ARIMA to. It will help us, it will generate the model. No? Sandali. Sign.r, asan si sign.r ko? Wait, pinalitan pa natin kasi yung pangalan, di ba? Okay, hindi na mag-run to kasi asan yung si sign.r natin? Dapat ito yun. I should have okay. Okay, hindi. Next one. Sorry guys, I'm changing the name. No? Okay. All right. Again, just a quick review, guys. Yung ito, sa 149, no? We're creating, not 149, sorry. This one. Hindi pa pala yun. Ito, no? ARIMA 10 natin. The ARIMA function will generate the model for us, no? Depende dun sa order na sinasabi natin. Okay, so we're using the SIMR. Hindi ko pa na rin yung SIMR na data, sorry. So let me run that first. Ito. Hindi ko na siya papaprint. So I generated the SIMR data. And then, I'd like to test, guys. I'd like to see SIM.r. Ito, no? This one. Wait. Ito, okay, 105. I'm generating this object ARMA10 kasi gusto kong i-model si SIMR na ARMA1, no? AR1, ARMA10 or AR1. So ito yon, no? Yung order niya 100. Remember, this is PDQ, no? P stands for the log of AR process. D is a difference. Q is the log of the MA process. And then, pwede natin i-include yung intercept or pwede hindi. No? So, if I run this, and lumalabas sa kanya, guys, binigay sa atin yung AR1 component, 0.5837. As expected, guys, dapat less than 1 to. Tapos yung intercept. Tapos yung AIC niya, 1206.88. This is only useful if you're comparing between models. No? Okay, tapos, ito naman, pag gagamitin natin yung auto.arima sa forecast package, this is a lot better, guys. Ayan, kaysa yung ARIMA tayo, kasi yung ARIMA lang, guys, isa-isahin natin yon. No? Diba ito? Pag ito lang gagamitin natin, we will have to generate several models like this, tapos papalitan natin isa-isa to. With this function, in the forecast package, auto.arima, automatic yan, mag-generate kagad ng, ng maraming models, and then it will give us the best value. In this case, the best value daw is ARIMA202. No? ARIMA202. So this is the P and this is the Q. So kasi si SIME, di ba yung si SIME R, generate natin yan using 2 lags of P and 2 lags of Q. Oh, nahulaan niya, no? Yun yung sinabi niyang best model, ARIMA202 with 0 mean. Okay? So ito yung ito yung sinasuggest na model. Okay. AR1 0.97 and then negative 0.48 and then negative 0.28 and then 0.15. Compare natin dun sa simulation natin. So i-compare ko lang to dun sa list natin, Control C. So let me just copy that here. Okay. AR 0.88, dito 0.97. Negative 48, negative 0.48, halos pareho. Negative 0.22, ito negative 0.28. Tapos ito medyo So may mga values na medyo malayo, no? Tapos may mga values naman na medyo malapit. So yun yung yun yung lumabas na model natin. Okay? So it will not be really exact kasi simulated yun no? Nag-set that seed tayo. So simulated siya. So we will not really have exactly the same model. Okay? All right, pause muna ako, guys. So far clear ba? Clear ba so far? Nabawi yata ito kasi yung SIME-R natin, yung AR1 process lang to. Okay, paki-chat naman please kung clear tayo so far, guys. Okay, good. How about the others? Okay, good, thank you. Okay, so yung fundamentals niya, guys, yung mga concepts niya, very straightforward naman. No? So pag may time series, check mo muna kung stationary yun. Kung hindi pa stationary, then mag-transformation ka, mag-data transformation ka, either log or differencing or even both. No? And then pwede kang mag-auto.arima na. Actually, guys, ito, yung auto.arima, let me just show this to you. Control C, Control V. If you recall, guys, yung ano ba yung data natin kanina? Hindi, ibang data pala yan. Yung AP data pala yan, no? Okay, sorry. Yung AP data kasi dati kanina yung air passengers, di ba? Pwede natin i-auto.arima yon even without differencing it or even without log transformation. Okay? Tapos magsasuggest siya kung anong differencing ang kailangan. So that's the beauty of the auto.arima function. Okay, so moving on, guys. The rest, yung iba dito, guys, hindi na natin i-ano kasi repetition lang siya. It's more of an example lang. No? Okay, additional example. Okay, I just want to point out something here dun sa auto.arima. No? Sa ARIMA. Dali ha. Kasi masyado mahaba na itong ano natin. Okay. Suppose here, guys, kunyari hindi natin alam kasi yung ano, di ba? Hindi natin alam na 2-2 yung model natin, ARIMA 2-2. So let's generate here I'll deliberately, Control X, deliberately mamaliin ko yung model natin. No? So let's call this ARIMA 1-1. Yung ano natin, yung simulated ano natin, time series. Let's call this one. Okay. Okay. So imo-model natin siya as a 1-1 ARIMA 1-1 process. No? Let's see what happens. No? Okay. Guys, sandali Sorry, andun yung Manila. Sandali guys, ipo-pause ko yung recording tapos paki-remind ako baka makalimutan ko. Sandali lang Okay, so here guys, kasi di pa sinimulate natin yung SIMR. So ang gagawin ko dito, deliberately mamaliin ko yung model. And let's see what will happen. No? Mag-generate naman siya ng ng output. ARIMA 1-1, tingnan natin Yan. So, andyan yung AR1, andyan yung MA1 natin, andyan yung intercept, and andyan dito yung AIC. Okay? Right. So this is the model daw. 0.4281 times SIMRT minus 1 plus 0.2578 times epsilon t minus 1 minus 0.0193 tapos minus a certain error term epsilon sub t. Yun ang model natin, ARIMA 1-1. But we know guys na mali ito, no? Kasi generate natin yung SIMR using a 2-2 process, no? So tapos i-check natin. We have to check the residuals, no? Hindi pa pwede guys na na ganun na lang 'yon, no? So Control C, i-plot natin yung residuals niya. Here. Plot yung model natin na ARIMA 1-1, plot natin yung residuals. Okay. So from the looks of it guys, ano naman siya, no? Mukhang stationary naman siya, no? Yun ang residuals natin, and then let's use the AC function. AC ARIMA 11, and then yung residuals ulit, and then max.log, we're natin 30. Yeah. Okay, let's see this. Okay, take a look at our correlogram. Okay, sa PACF guys, kita natin, oops, may mga significant lags pa. Pag ganyan guys yung residuals natin, ibig sabihin, pwede pa natin ma-model to. So ibig sabihin, hindi sufficient yung ano natin, hindi pa sufficient yung model natin kasi may mga significant lags pa tayo dito, no? Pati din dito, okay, both in the ACF at saka PACF. Okay, so that's what happens guys when we misclassify or give a wrong model using the ARIMA function. Ito ginamit natin si ARIMA function ulit, tapos ang order natin 101. Okay, ARIMA 1-1. So, ang lalabas dito guys, okay, mag-generate ng model, pero pag chinek natin yung autocorrelation function natin, ayan, ibig sabihin nun, hindi pa okay yung model natin. how should the residuals, how should the correlogram of the residuals look like? Guys, how should it look like? 2 words, guys. Ano dapat yung nature ng residual ng correlogram ng residuals natin? Dapat wala ng mga significant spikes dyan. No? Anong tawag doon, guys, pag wala ng significant spikes? 2 words. What are those 2 words that will describe that? WN, ano yung WN, guys? What's WN? It's class. It's called, kalimutan niyo yan. Oops. It's called, okay? It's called white noise, no? White noise na dapat siya, guys. Okay. Tingnan natin, guys, yung ano natin kanina. Ito. So, asan na siya? Anong model yun? Makita. Sige, palitan ko na lang ito, ha? Okay. Let me reproduce this. Control C. Control V. And let me use the correct model. ARIMA3. So this is 2. This is 2. Wag na ako maglagay ng mean is equal to false. But without mean yata yung model. Hindi ko na ipa-plot to. I'll just use here 2, 2, pa-print. And then residuals with 2, 2. Okay. Here, guys, I'm generating another, ito yung ARIMA model natin, ARIMA. And then 2, 2 siya without the mean. Tapos ipa-generate yung results itong ARIMA2, 2 and then plot the AC. Okay, run natin to. Okay, first, ito yung model natin, no? Itong AR component, AR1, AR2, MA1, MA2. And then let's take a look at the ACF to ACF. There, guys, tingnan nyo. Diba? White noise na siya. White noise na siya. Ibig sabihin, okay yung model natin. Yung ARIMA2, 2. Okay, let me pause for a while, guys, kasi I might be discussing this too fast. Yeah, thank you, Ziska. Yes, you're correct. No? Sorry, hindi ko nakita yung answer mo. Yeah, Ziska is correct. It's a white noise. No? Okay, let me pause for a while, guys. May questions ba? Ito yung goal natin. Dapat yung model natin, pag pinat natin yung residual siya, yung kinuha natin yung autocorrelation function, dapat ganito siya. So lahat ba ng models, guys, magiging ganito? No, guys. There will be instances na hindi pa rin magiging ganito kahit na yun yung sinasuggest na best model ni Auto.ARIMA. When that happens, guys, it's indicative that maybe hindi lang ARIMA dapat yung gamitin. Dapat ArchGarch na yung gagamitin. Okay? Kasi ibig sabihin nun, may mga volatility na hindi na mo-model na ni ARIMA. Okay, pause, guys. Questions? Paki-chat naman kung clear so far. Waiting for the others to please chat. Dalawa pa lang nag-chat, guys. Thank you, Migs. Thank you, Julia. How about the rest, guys? Don't be ashamed, guys, to ask questions if you need clarifications. Hindi sprint to, no? Marathon yung lesson natin, hindi sprint. Okay, thank you. Although guys, 4 lang yung nag-respond. Ano? Sana more responses kasi I want to know kung okay yung ano natin. Okay, so just a quick review here, although yung 2-2 model na ginawa natin. 2-2 and then 2-2. Kasi ARIMA 2-2 guys, di ba? It's a list, no? If we highlight this, yung list ng ARIMA 2-2 natin, let me, yan. So may coefficient siya. Andito yung variance, sigma squared, variance that coefficient, and others, no? And then residuals. No? Okay, so ang names nito, yan. Ito yung mga laman ng ano. We can easily access, for example, ARIMA, object natin ARIMA 2-2, ARIMA 2-2. If I want to get the AIC, for example, yan. Okay, it will give us the AIC, no? ARIMA 2-2, and the others also. Andiyan nakalist naman, mayroong IntelliSense ang ano ang R. No? Okay, ano yung sigma squared na yan? Okay, so this is the standard variance, no? Okay, etc. Coefficient naman ito, yan yung mga parameters natin, no? And then ARIMA model. Okay. So dito may mga lumalabas guys sa ibang measures, no? Pi, theta, ano to? What are these? Okay. What's phi, no? 0.917. Ito 'yon, no? Ito yung AI1 natin. Okay? In many of the books, guys, pag minomodel natin, ginagamit natin yung phi na ano, phi na okay. Will it run here? Let me try. So ito yung sine r underscore sub t is equal to ano yung unang ano natin? I'm writing the model lang. At least yung first ano lang. This one, Control C, Control V, and then times, okay? And then phi underscore p minus 1, okay? Plus MA naman. Yung ano lang, yung dalawa lang to, just to give the example. Control V times theta underscore t minus 1. Okay, ayaw mag-run dito. Dito ko lang i-run. Control C. Okay. In many of the standard books, guys, yung AR1, it's denoted as phi, no? Phi t minus 1. Tapos yung MA component, theta ang ginagamit sa kanya. Okay? So I hope that's clear, guys. Baka tataka, bakit may ano dito? Ba't sa model may phi at saka theta? Those are just the AR components and the MA components. Okay. Clear ba yun, guys? Kasi standard na ginagamit talagang 5 yung component ng ano, as the variable for AR and theta, the variable for ano, karamihan yun ang ginagamit. Sa atin, para i-simplify lang, A1, A2, and then B1, B2. But we can use this also. Okay, so let me move on kasi pare-pareho lang naman to guys, ano? Inulit lang tong ano na to. Inulit lang yung mga examples dito. I would like you yourself to just look at this. Okay. I think I will have to, ito muna tayo guys. Okay, dito, just to illustrate to you the difference between AR1, AR2, AR3, and AR4. So, dito mag-create tayo ng plots, no? Partition, 4 rows and 3 columns. Tapos ito yung function natin. You don't have to understand all of this. Pero ito, gagamitin natin si P as a variable, denoting 1 to 4. And then ito yung function natin. Ipa-plot natin yung time series, AR.mods, no? Ito yung object natin. Tapos yung P, okay? Tapos lalagyan natin ng yung ylab, lalagyan natin, ipe-paste yung AR function. Tapos kung ano man ang P sa kanya. Okay, and then plot the ACF and the PACF. Okay, so you don't have to understand everything here at the moment. Okay, but you can on your own take a look at that. Kasi ito yung maganda guys sa R, you can create functions. No? So i-run muna natin to. Okay, so saan ako nagkamali? Okay, dali Ay, sorry. Sorry. Dapat kailangan i-run muna natin to. No? I missed out on this. Okay, ito yung preliminary. Ano, we're creating this object ARP and it consists of 0.7, 0.2, negative 0.1, tsaka negative 0.3. Okay? Tapos, nag-create tayo ng object na AR.mods. List siya, yung P from 1 to 4, and then AR.mods will be P. No? And it will simulate an ARIMA with 10,000 observations. And then ang list niya, yung AR is equal to ARP from 1 up to P. Ang P natin, di ba, 4, no? 1 up to 4. And then with the standard deviation is equal to 1. So let's run this first. Okay. And then run ulit natin to. No? So magpa-plot siya. There. Okay. So i-generate ko itong plot na to. All right. Par, MF row, 4 rows, yan, 4 rows and 3 columns. Okay. Ito yung unang, kasi di ba sabi natin mag-generate mag-simulate ng ARIMA, no? Yan, no? Yung una natin, asan na siya? Okay, ito guys. Simulate ARIMA 10,000 observations. Okay, 4 na ARIMA, no? Yung 1, ito lang yung ano natin, ito lang yung component na. Yung ARIMA 2, 0.7 at saka 0.2. Yung ARIMA 3, 0.7, 0.2, negative 0.1. Yung ARIMA 4, yung 4 na to. No? Bali, AR4 process natin dulon-dulo. So this is okay. Yung AR1 kasi 0.7 less than 1 siya. This is okay, 0.2. Pag ARIMA 2, pag ang ARIMA 2 ang ginagamit, ARIMA 2.0, no? 0.7 at saka 0.2 is okay kasi less than 1 yung sum ng mga parameters niya. ARIMA 3 naman, 3.0 or AR3, 0.7, 0.2, negative 0.1, that's also okay. Lahat sila less than 1, yung sum nila less than 1. Kung 4 naman, itong 4 na to, okay din siya. Individually less than 1, yung sum nila less than 1 din. So pwede tayo mag-generate ng ARIMA simulated model, no? With 10,000 observations. And then, na-generate natin ito. No? Let me once again show that. Okay, take a look at this, no? Ito yung AR1 guys. Ito lang yung ano, ito lang yung 0.7. Okay? So ito yung plot niya. Okay, it looks stationary, no? Tapos tingnan niyo yung PACF, no? PACF niya, significant spike at lag 1. As expected kasi AR1 process eh. Slow decay sa ACF. Okay? AR2, significant spikes at lag 1 and lag 2. Diba? AR2 process to. So dito mahuhulaan natin, no? AR2 process, significant spikes at 2, at lag 2, lag 1 and lag 2 sa PACF. No? ACF guys, slow decay. Notice nyo, lahat to AR process, panay slow decay yung ano, yung ACF natin. Take a look at AR3, you know, significant spike at lag 1, lag 2, and lag 3. Diba? AR3. Notice guys, positive, positive, negative. Diba? Positive yung AR1 natin, kaya positive to. AR2 natin, positive, positive. Yun yung mga coefficients natin, di ba? 0.7, 0.2. Tapos negative 0.1 yung lag, lag 3. Tapos dito medyo hindi na tumama ng konti, no? Kasi positive yung lag 1, negative si lag 2, although maliit lang siya. Okay? Ito, negative si lag 3, negative si lag 4. Slow decay, no? Yung ACF. So this was meant guys to summarize and compare yung differences ng PACF at saka ACF ng isang AR process. Yung differences ng ACF, PACF ng AR1, AR2, AR3, AR4 processes. Okay, you can see it here. Okay, pause guys, questions. Questions? I hope guys I'm not explaining this too fast, no? Buti na lang may video na pwede nating pwede nyo i-review. Okay? All right, questions guys? Okay, thank you Azi. Yung iba guys, sana klaro sa lahat, no? Okay. Just this last one. Tingnan naman natin guys yung MACF. Ganon din dito, no? Same coefficients. MA naman to, no? So i-run natin to. This time we're using an MA, no? MA naman to, no? Ang list natin MA. So run natin to. And then run natin tong pangalawa din. Here. Okay. Let's take a look at this. MA process naman. Okay. Hearing you guys, no? Okay. MA1 natin. Hearing nyo, dalawa yung significant, no? Sorry guys. Ito lang yung significant, ha? Apologies guys. Hindi ito yung significant, ha? Kasi lag 0 to, ano? Ito yung lag 1. So tama to. Significant at lag 1 sa ACF. Pero dito, slow decay, no? Nag-alternate siya. Pero slow decay siya. And then MA2, significant at lag 1, lag 2. Yung 0, guys, talagang talagang 1 yan. Kasi anong correlation ng time 0 sa time 0? 1 talaga yon. No? Kaya yung iba guys, hindi na pinapakita to. Lag 1 na kagad yung pinapakita. But in this case, pinakita yung 0. Kaya dapat talagang 1 yan. Perfectly correlated si time t kay time t. No? If you get the correlation of sine r with sine r itself, edi 1 yun. Kasi pareho lang yung mga values na tinitingnan natin ng correlation. Okay, if you notice yung mga PACF natin, medyo so slow decay siya, no? Yan, no? Gumaganon. Slow decay. Tapos ito naman, mga significant at lags, no? Ito, significant at lag 1, lag 2, meron pang konti sa lag 3. Okay? But of course, guys, just from experience, hindi nyo talaga mape-perfect na na ma-identify kung ano yung kung ano yung eksakto na na MA model or AR model or ARMA model. That's why dati, nung gumagawa kami ng ganito, talagang pahirapan kasi hahanapin mo yung iisa-isahin mo. Parang nag-aarima ka dito. 100, 101, 102, 201, 202, etc. No? Talagang magta-trial and error ka and compare the AIC for those different models. Okay, but with Autodot ARIMA, guys, ang dali-dali na, no? No more sweat, no? So ang object, ang ano na lang, yung pag-explain na lang. Okay. All right. So I'll skip this, guys, kasi ano lang yan, inulit lang yung ano, no? Inulit lang yung pag-explain. I think I have to fix my notes kasi parang nauulit-ulit yung iba, no? Okay. So dito, okay. Ano ba raw yung relationship between an AR1 process and an MA1 process? Maybe we can backtrack here a bit. Okay, how does an AR1 and an MA1 process look like? Okay, for AR1 and MA1, sabi natin dapat yung ano natin, yung A1 natin, yung absolute value niya dapat dapat less than 1. So pwede maging negative, no? Pwede maging positive, pero dapat hindi lalampas sa absolute value ng 1. Okay, ganun din si MA process. So, for example, ito equation natin, AR1 process is A1 times Y sub t minus 1 plus epsilon sub t. Ganun din si MA1. The coefficients of the AR1 and MA1 can't be greater than 1 and can't be less than negative 1. Yung absolute value niya should be less than 1 always. Okay, naulit lang yun siya. Okay, ano ba gusto nating i-ano dito, no? Okay, here, magsa-simulate tayo ng AR1 process, no? ARIMA sim 500 observations. AR is equal to, maliit lang A1 natin, no? 0.1 lang, no? So this is 0.1. So standard deviation is equal to 1, and then we just add a certain small number, 1. Okay? And then ipa-plot natin time series. Okay, run natin to very quickly. Okay, as you can see, it's a stationary time series, no? It's a stationary time series. Tapos, anong ginawa natin dito? Palitan na lang natin to, gawin natin AC. AR1.small. Para hindi natin iisa-isahin yung pag-plot ni, okay, sige, 18. Okay, instead of using these two, okay, pwede natin gamitin yung AC function coming from TSM. Alright, tapos i-run natin to. Okay, so ito yung plot. Ito yung plot, no? So as you can see here, AR1 to, no? And di ba? So significant at log 1. Tapos si MACF, so sa MA, no? Parang sa MA, si ACF, guys, no? Significant din siya at 1, pero parang slow decay na parang hindi, no? So this is where the difficulty lies minsan. Very apparent dun sa PACF, but it can be not apparent so much in the ACF. But definitely, may AR component to. No? As to MA component, hindi natin sigurado. And then, tingnan natin itong isa pa. No? So ito, isa lang yung pinakita niya, no? ARIMA. Notice, guys, no? Ang best model is an ARIMA 001 with mean is equal to with non-zero mean. Okay, ang series natin, AR1 small. Okay. So, ang question ko sa inyo, guys, no? Bakit kaya yung sinimulate natin na AR1 Okay. Bakit kaya lumalabas dito ang best model sa kanya is an MA1 process? Di ba guys, tingnan nyo? Okay, let me, ito pala, binigay niya. Now, take a look at this. Yung ARIMA 100 with non-zero mean, ang AIC niya 1450. ARIMA 100, wala siyang 100 with mean. And then ARIMA 001, ito, with non-zero mean is 1448.725. Yan. Okay? So take a look at this. Yung sinimulate natin as an AR1 process, ang lumalabas guys, mas maganda yung MA1 process. Kasi by virtue of having a smaller AKI information criterion. Okay? Non-zero mean dapat. 1448. Yun ang lumalabas dito sa sa model. Okay, ito yung mean, ito yung MA component, at saka ito yung mean. Now, okay? So I'd like you to research guys, ano kaya, bakit kaya ganun? Akala ko foolproof tong auto.arima. Di ba nag-simulate tayo ng AR1 process? Ito yun, di ba? This is an AR1 process. You know, list AR is equal to 0.1. A very small phi1, no? Yung component ni AR1. Bakit ang lumalabas dito? Bakit minumodel siya as an A1 model? Okay? I'd like you to find out why, guys, and tell me the answer next meeting. Okay, kung bakit kaya yung supposedly AR1 model, guys, naging MA1 yung model, no? So ang question kasi, what's the relationship between an AR1 model and an MA1 model? Okay, so I'd like you to research on that, guys. I leave the answer to you. Okay, ito naman guys, malaking naman, no? Malaking AR1 component 0.9. Yung kanina 0.1 lang. So in the interest of time, guys, I'd like you to take a look at that. Tapos tingnan niyo yung sige, ilan na natin to para mas makita na natin. So ito din, guys. So i-run muna natin using the forecast method. So this is now, hindi siya yung small a, guys, big A, no? So anong difference ito? If we run this, okay, anong ginagawa nito? Magge-generate siya ng model for the AR1.small na 100. Okay, so ano lumabas? Okay. Ito yung notice, guys, no? Ano lumabas? Okay. So ito, sinabi natin na dapat ang order niya 100. So ang lumabas dito yung AR1 component. Okay. So ang tanong, anong difference ito? Ang AIC nito 1449. 1449. Pag gamitin natin si AR1, 1449 yung AIC niya. Pero ang sinasuggest ng auto.arima, okay, is MA1 kasi 1448 ang AIC. Okay, so ang tanong, bakit naging ganun, guys? Bakit naging ganun? Alright, so ito naman, tingnan natin to. Ito naman, AR, malaking AR, 1, 0.9, malapit sa 1. So let's just quickly run this. Okay, so ito yung plot niya. And then, nag-difference siya dito, no? Okay. Okay lang, guys, ha? I think nasobrahan ko ng mga ano to, no? Okay. So, alright, anong ginagawa natin dito? Okay, ang kulang ko dito, hindi ako naglagay ng mga notes ko dito. Okay, ito, nag-run tayo ng AR1 is equal to 0.9. Okay, nung plinat natin, it's stationary. Tapos, we ask R to, ito muna, mag-generate siya ng ARIMA model, AR1 process. So, ang lumabas sa kanya is 0.8642, no? Which is really close to 0.9. Okay, pero guys, pag pina-auto.arima natin, okay, pag auto.arima, ano lumalabas? Okay, ito iba naman guys, no? Yung ARIMA, yung AR process natin na malaki yung AR1 component natin 0.9. Notice ang sinabi niya dito, mag-differencing ka. 0, 1, 0 means you difference the data. Okay? So this is what ito yung sinasabi sa atin na ang mag-difference ka 1477. Kasi kung ang gagamitin natin itong AR1 process, okay, ang AIC niya is, hindi tuloy gamitin to. Okay, AIC niya is 1452. Eh, pero pag nag-auto.arima tayo, yung auto.arima natin kanina guys, anong suggestion niya? Ito. 1452 pag AR1, pero pag auto.arima, ang suggestion niya is difference, no? Difference, ito, 010, no? And then the akaiki is higher. So medyo may conflict dito, no? Time na. May conflict dito, guys. So next, kindly look at this, guys. Paki-research naman kung ano difference ng AR1 process at saka MA1 process. Okay? Tapos ano yung nature ng isang AR1 process na maliit yung AR1 at saka malaki yung AR1. Okay? So we'll pick it up from here next meeting. And then kung pwede guys, pag nagpunta na tayo sa Monday guys, paki-load na tong from the quant mode, i-load na natin yung Apple stock prices kasi ito ni last example natin for ARIMA. Okay, we're going to finish this on Monday. Okay, i-model natin si Apple and then see what will be the time series model for an Apple price, no? And then mag-introduction na tayo ng GARCH. Okay, so let me stop recording now.